what are they telling me right here? And right here, and right here. They're really giving me points. These points are intercepts. So all these guys are intercepts. So the intercepts we have are going to be 0.80. That's one of the x-intercepts. We're also going to have negative 2.30. These guys are both x-intercepts. What's my y-intercept going to be? It's going to be 0, negative 2. This is the y-intercept. These guys form the anchor points for my graph. Okay. So if I come down over here, I can plot these points. So negative 2.30, that's about right there. Okay. 0.80, that's about right here. And 0, negative 2, that's about right here. Is there any questions about what's happening so far? All right. What's this next part right here? This next line? It looks like they're giving me, you see this infinity here, this negative infinity here. This positive infinity here, this negative infinity here. These guys are telling me vertical asymptotes. So, I just realized that my warm-up didn't have vertical asymptotes. In the past, I've done more than one warm-up. I've done 2 warm-ups, one that has a vertical asymptote and one that doesn't. But, you know, whenever you approach something and it goes to infinity or negative infinity, that's what vertical asymptotes look like. So when I look at this, I hope you guys can see that it looks like we have 2 vertical asymptotes. One vertical asymptote occurs at negative 2, and the other vertical asymptote occurs at 1. So we're going to label those vertical asymptotes in. Okay. So let's do that. So let me do my vertical asymptotes in red. Let me you do the dashed line. So negative 2 is right here. Sorry, that's supposed to be more glorious. It's supposed to be straight too. I'm about to give up. That's pretty good. There's also a vertical asymptote at negative 1. That's good enough. Okay. And they even tell me like the direction that it's going to go. So if you look, if I come from the left side of, if I come from the left side of negative 2, it's going to go to positive infinity. So I can represent that easily. I can just come to the left side of negative 2, and it's going to go up to positive infinity. So maybe my graph is going to go like this. I can come from the right side of negative 2, it's going to go to negative infinity. So it's going to come like this, like that. What about at 1? From the left side of 1, it's going to go to positive infinity. So maybe this part comes up like this. Oops. This graph is too small, like everything's too cramped. It's not really easy to draw. And then if I come from the right side of 1, it's going to go to negative infinity. So I already have a sense as to the general shape of my graph. So the first line gave me intercept information, it was a bunch of points. The second line gave me vertical asymptote information. I could see that with the infinities here. Anyone tell what the third line gives me? What do you think the third line is giving us? Any thoughts? You can unmute yourself if you have a thought for this third line here. And this is not obvious. I take it it's not obvious. Okay, it's not obvious. Do you see how I'm taking the limit as x goes to negative infinity? The limit as x goes to positive infinity. This is really behavior at infinity. Or end behavior. And in this case, they don't go to positive infinity or negative infinity, they go to a number. So if the limits at infinity go to a number, what does that tell you? That's right, it tells me I have a horizontal asymptote. Right, so let me just remind you. Oops, 3.4, not 4.4. Talked about limits at infinity. Before you take the limit, you go to negative infinity, or you take the limit as you go to positive infinity, right? If it's equal to a number, that's when you have the horizontal asymptote. This is the exact situation that we're in right now. Vertical asymptotes occur when you have a 0 in the denominator, right? So, so the different options were it goes to some sort of infinity, or it goes to a number, or it's undefined. In our case, it goes to some sort of number. So this is the horizontal asymptote case. Okay. So coming back here, we have a horizontal asymptote. Horizontal asymptotes are like y equal to some number. In this case, it's y equal to -2. So I tend to use dotted lines to graph my asymptotes. So I'm going to come down here. Here's my -2. I'm going to use a dotted line. I'm just going to go to -2. I'm just going to draw a dotted line. So we should label our asymptotes when we do this graphing stuff. So my horizontal asymptote is y equal to -2. My vertical asymptotes were x equal to -2 and x equal to 1. I can kind of see this graph taking shape now. I'm guessing this guy is going to come down like this. This guy is going to come up like this. That's my guess. I'm not sure yet. I have to look at the increasing, decreasing, and the concavity information to tell me that. Any questions so far? All right. Let's figure out where this guy is increasing and decreasing. So we're going to draw a little number line. When I look at this line right here, do you see how this line involves the first derivative? They're telling me where it's greater than 0. Okay. So when I look at this, it seems like I have some important points here. -2 is an important point, and 1 is an important point. So I'm going to have a -2 here. I'm going to have a 1 here. And what do they tell me? In this particular case, they tell me, man, on all of these intervals, the derivative is greater than 0. What is the derivative that's greater than 0 tell you? Increasing or decreasing? What do you think? That's right, it's increasing. So positive derivative means it's increasing. So it's increasing on all three. Okay, cool. Let's take a look at the concavity. Really, I should just copy the old graph. Here, let me just copy the old graph here. Let me delete this guy. Well, I'm going to copy it down here as well. Okay. So they just gave me increasing, decreasing info because it involved the first derivative, right? The first derivative always tells you about increasing, decreasing info. The next line here tells me about the second derivative. Second derivative tells me about concavity. So concave up means it's positive. Positive means it's concave up, right? So there's two intervals where it's concave up. It's concave up here. And oh, you have an extra point. Do you see how this goes from 0 to 1? So we need to label in a 0 here. Let's put 0 here. So from negative infinity to negative 2, it's concave up. From 0 to 1, it's also concave up. The second derivative is negative from negative 2 to 0. So from negative 2 to 0, it's concave down. And from 1 to infinity, it's also concave down. Is there any questions about this? All right, cool. So now we're going to piece these guys together. Concave up and increasing, it looks like this. Concave down and increasing, it looks like, whoops, I need the 0 in there. Put the 0 in here. Concave down and increasing, it looks like this. Concave up and increasing, it looks like this. And concave down and increasing, it looks like this. Is there any questions about my curved arrows? Joe, I just saw you typed increasing in the chat box. You're right. Thank you for supplying that. I noticed 2 minutes later. Now I just want you to imagine we're gluing pieces to make this thing work. So from negative infinity to 2, it's concave up and increasing. I think I can draw that. I think that looks like this. Like that. From negative 2 to 0, it's concave up, a concave down and increasing. So it looks like this. From 0 to 1, it's increasing. So it's going to look like this. And then the last one, it's concave down, increasing, but it has to hug this asymptote. So I think it looks like this. Actually, let me do this wrong for a second. Let me do this wrong for a second. How come it doesn't, how do I know it doesn't look like this? No, it could still hug it could go over the asymptote and then still hug it. How do you know it doesn't look like that? Does anyone want to unmute themselves and explain why this answer I have here is incorrect? There's many ways we could see it's incorrect. Anybody want to play today? No one.
Because the limit from x to positive infinity is a function of -2.
But this guy does go to -2 as you go to positive infinity.
But doesn't go above the -2.
Oh, how come it can't go above the -2?
Because on the second derivative, x is 0 0 from minus 2.0.
Okay. I think you're kind of onto something here. One thing I would say is the way I've drawn it, if it kind of comes up and then comes back down, it has a local minimum, a local maximum here, right? But there's no local maximum at all. It's always increasing. So if it crosses the asymptote here, it's decreasing on this part right here. But according to our first derivative information, it's never decreasing. So that's one way you could see that it wasn't correct. Sometimes students mistakenly think that you can't cross an asymptote. That's false. You can't cross a vertical asymptote, like because the function's undefined there, but you can totally cross a horizontal asymptote. We crossed it right here. Crossing a horizontal asymptote is not an issue. However, this guy is concave up and increasing and hugs the asymptote. It looks something like this. It cannot go up and then come back down. That would be reflected in the increasing, decreasing info. Okay.